In this lesson, we're just going to quickly talk about the variance inflation factor. We touch on it a couple of times. It's an important thing, and we just want to go through an example of it to show you some of the features that it has. So the definition was given as variance inflation factor is 1 over 1 minus the r squared of uh, all with the subscript j, where j is the predictor that we're looking at the variance inflation for. So each predictor in our data set has a variance inflation factor that's associated with it. So that's where this j comes from. So I'm going to walk through how to calculate this in Python. I've used R before. I thought I'd use Python for this one just so that we're not stuck on one particular way of doing things. So I'm going to start by reading in some of the packages that we need. So pandas is just very nice for a lot of things. We're importing something called linear regression, something called R squared, variance inflation factor, and add constant. These are just little things that help with doing a linear regression. Gives me this error that there's a deprecated something. Not too worried about that. And so I've read in the comma separated values file, the CSV file that should be available on Owl's resources. This is just code to make sure it comes from my Google Drive so that it's available to it. This is the code that we actually need in order to fit the model. So what I'm doing is I'm creating a new matrix called X. It's given the value of birth being the data that I brought in. It's taking that data only at the columns called smoker, mother's height, and mother age, and then I'm adding a constant to it. And then y, my response variable, is going to be birth just at the column labeled birth weight. And then I'm going to fit a linear regression of y against x, so it just knows that since x has a constant, smoker, m height, and mother age, these are my predictor variables for this linear regression, and y is my response. And so if I run that, it fits it just fine. And then there's some fun code to calculate the variance inflation factor. So there's a function called variance inflation factor that takes in the values of x, not the names, just the values themselves. And I tell it which column I want to calculate this for. So I'm starting by creating something called VIF of variables, and it's just a data frame with a single column, named variables, and the variables are just the names of the columns of x without the first value. So 1 until the end means I'm getting rid of that first value, so I'm removing the constant. And so I'll just run this so that you can see what comes out. So variables is smoker, m height, and mother age. And I've got the variance inflation factors for each one of those. And so variance inflation factor, again, I want to stress, is just calculated based on x. There's no y. So in this code chunk, I've have a model fit, and I have a response variable y as well as x. In this code, y does not appear. The fit that I did doesn't appear. It's just x. I only need x in order to calculate the variance inflation factor. And so I get it for smoker, it's 1.04, which is very small. A general rule of thumb is that variance inflation factors above 4 are something to look into, or possibly troubling. And so they're all quite low. They're 1.0 something after that, 1.048 for 2 of them, which is a neat coincidence. But just to make this make a little bit more sense, I want to go into actually calculating it by fitting regressions themselves, just to show how to do that. I'm doing the same thing I did up here. So fitting the model is using linear regression.fit. I'm fitting a linear regression. My X matrix is X at constant, smoker, and M height. My Y is X at mother age. So mother age is my Y variable, constant, smoker, and M height are my X variables. So that's beta naught, beta 1, and beta 2. The birth weight, which is my response variable, does not appear in this. Nowhere will you find birth weight. And if I run this line of code, it first prints the r squared value from this model. So r squared scores based on the true values and the predicted values. this is fitting a basic R squared, it's not fitting an adjusted R squared, but that's not important for what we're doing. It prints the R squared, which is very low. The R squared value is 0.046. And then I'm printing 1 over 1 minus the R squared value for the regression of age against the other predictors. And I get 1.0489, which is exactly what I got up here. And similarly for these, again, birth weight doesn't appear anywhere in here. Birth weight doesn't matter for this. I'm calculating the R squared values for the regression of one predictor against all of the other predictors in the model. And I get 1.00312, 31248, which this one rounded to 3125. And same for this final one. For smoker, I'm calculating the R squared from the linear regression of smoker against all of the other predictors in this model, and I get exactly what I saw before from the variance inflation factor, except many more decimals. And at this point, I want to just make a quick note that variance inflation factor for a binary covariate, so smoker is only 0 or 1, it doesn't make much sense to do a linear regression of smoker against other covariates. And so in this case, the variance inflation factor isn't the most meaningful thing to look at, so it's very low here, but that's, since it can only be 0 and 1, it's unclear exactly what a variance inflation factor means for smoker. So in this case, you would want to do something either with visualizations or just look at a contingency table or something like that. Just looking at a linear regression isn't much sense. So that's all I wanted to show you for this quick video. The main takeaway message here is that the variance inflation factor is calculated as the R squared from a regression of each predictor variable against all of the other ones. So you go through age against all of the other ones, smoker against all of the other ones, height against all of the other covariates, and find the R squared from that. 1 over 1 minus the R squared is our variance inflation factor. None of that includes the response variable. So it doesn't matter what the response variable is in order to calculate the variance inflation factor. The VIF isn't actually modeling something about the relationship between the predictors and the response. The variance inflation factor is only saying something about how correlated our predictors are.